Hey there. This time the interview question is about JavaScript types. And the question is going to be a bit different. Instead of one large question, it's going to be a series of smaller ones. So let's take a look. All right, here we have the set of questions, and the primary prompt is what do each of these lines evaluate to? So first we have this double type of line, a bunch of additions with various data types. We have these couple of weird looking lines with the less than signs and greater than signs, and then the final type of line checking on the array. All right, now there's definitely a lot of JavaScript trickery going on here, but the trick to each of these questions is to remember the principles of JavaScript. There are details in this question which you can learn about by coding in JavaScript over time or by doing a specific study on JavaScript types. So let's go ahead and take a look. We're going to start with this type of line. The first thing to remember for types is that JavaScript is a dynamic language. So if you're coding along, I would recommend opening up your own instance of the browser development console. Go ahead and inspect the element by doing a special click on your browser, selecting inspect, and then go ahead to this console tab over here. So JavaScript is a dynamic language, which means when you create a variable, you're not required to say what the type of the value is for that variable. You can set it to that variable name without specifying that 1 is a number. So if you evaluate foo, it's still going to retain that number. Likewise, you could just as well have declared foo to contain a string. So returning foo is going to retain that string value. Just as well, you could have made it a Boolean. So the point is that JavaScript is dynamic. Unlike in static languages, you're not required to declare the type of the variable before you actually assign it. This is distinct from, again, static languages like Java, where you have to say string foo equals that string, or rather the string foo, or number foo equals 1. Here you're seeing that the type is statically declared. But this doesn't mean that JavaScript doesn't have types. Even though these values are dynamically typed, all of these variables will still have a data type, which can be verified by using this type of operator. So type of 1 is going to return the string number. Likewise, type of a string is going to return a string that says that type of the value is string. We can do the same thing for a Boolean. So the type of true is Boolean. So this gives a hint on how this type of line is going to work. Notice that each of these type of values returns a string. For a number, it's returning a string that says number. For a string, it returns a string that says string, and for a Boolean, it's a string that says Boolean. So all of these are returning a string. So if you apply parentheses around the order of these operations, then it can be figured out. Type of 1 will return a string that says number. And the type of a string is string. So if type of 1 is indeed number, well, type of the string number should be string, which means that overall type of 1 should be string. So we figured out the answer to that first question. It returns a string. Okay, next up we have the second set of questions, which is a bunch of addition with various data types. Let's start with this first one. It's a string 1 added to the string 2. So this will be string concatenation. To figure out how string concatenation works, let's go ahead and try this in the console with two other strings. How about the string foo plus the string bar? So string concatenation joins the two strings together as one word. Now, this gives us a clue on how the string 1 plus the string 2 is going to work. Just because the contents of the strings are numbers doesn't mean that normal addition on numbers is going to work here, or rather going to apply here. What's going to happen is the normal string concatenation. So the string 1 plus the string 2 is actually the string 1, 2. So the string 12. So this returns the string 12. But now we get to something different. It's the number 1 plus the string 2. So how is this going to work? Well, JavaScript in addition to being dynamically typed, is also weakly typed. In a weakly typed language, values can be converted to different data types when used in operations. And on top of that, the conversion is implicit. So if there's an operation with a data type of one kind and another data type, one of those values is going to convert under the hood. So that way the operation can be achieved. So to see how the number 1 plus the string 2 works in JavaScript, first let's explore how this works with an explicit type conversion. So go back to the console, have the number 1 plus the string 2. This would be implicit, but use the number constructor around that string 2. So as seen, the number constructor converts the string 2 to the number 2. So that way 1 plus 2 could be added to equal 3. But if the conversion is implicit, how do we know that the string 2 is going to be converted to a number? It could just as well be the string constructor around the number 1 plus the string 2. And in this case, it's an operation that we've seen before. It's the string 1 plus the string 2 to return the string 1, 2. To dig into how this is going to work, let's explore this with a for loop. We're going to declare a for loop that starts I at 0. I is going to be less than 5, and we'll have I increment at every iteration of this for loop. Then we'll do console.log of step as a string with a dash plus the I variable itself. So notice that there is a string data type here being concatenated with the number data type for this I variable. If you run this, you should get step 0 to 4 within the console. So this is an implicit conversion of the I variable into a string, so that way concatenation can be achieved. So in this case, JavaScript chose to convert the number into a string. So the implicit choice for the addition operator with a string and a number is to convert that number into a string, and for a good reason. Converting the number into a string is the more likely scenario. After all, in order to make a number a string, all you have to do is surround that number with double quotes. But there's far less strings which are applicable as numbers. In order for the string to be a number, the content has to be a number. But there's so many strings like foo, bar, camera, etc. So this gives us a clue of how 1 plus the string 2 is going to work. What is favored is converting the number to a string. So therefore 1 plus the string 2 is going to be what we've seen before. It's that string 1, 2 because string concatenation is performed. So string 1, 2 is what is returned. All right, next we have a pretty interesting one. 1 plus, and then the plus sign again before the string 2. So to dig into this, let's go back to that number constructor. The number constructor around a string returns the number value for that string out of its content. So the plus sign before a string does the same number constructor conversion, but implicitly with the plus sign. So it's going to try to parse the number out of this string, which happens to be 1. This works for decimals as well, so plus 0.5 returns the 0.5 number, plus a negative number within a string is going to return that negative number itself. So we can have a negative and a decimal, and negative 0.9 is returned. So this should tell us that this plus the string of 2 will return the number 2, and 1 plus the number 2 is going to be a regular addition of numbers, so that returns 3. All right, and now we get to this next one, the Boolean true plus 1. And notice again that they're different data types. So JavaScript is going to do an implicit type conversion so that way the operation can be achieved. Now the question is, what is the number value of this true Boolean? Now on binary terms, true has a value of 1 and false has the value of 0. 0 represents something that is off, like an electrical voltage, so false is the intuitive value to apply to that. Likewise, true has a value of 1 because it represents something that is on, which means in the console, if we add true plus 1, what we're really adding is 1 plus 1, because JavaScript represents the number value of the true Boolean as 1. So true plus 1 is actually going to be 1 plus 1, which is 2. To complete the example, how about false plus 1? False should have the value of 0, therefore 0 plus 1 is 1. So we've seen that true plus 1 is going to be equal to 2. Cool. Now we get to these lines with the less than signs, 2 of them, and then the greater than signs, 2 of them as well. The trick to this one is to apply the same trick as line 4, where we have the type of. This is all about order of operations. For this overall line, the first thing that is going to apply is 1 less than 2. So first we have a set of parentheses around this, and certainly 1 is less than 2, which gives us the value of true. Now the question is, well, is true less than 3? And we saw that true has the value of 1. So is 1 less than true? Or rather, is 1 less than 3? And indeed, that is true. So overall, the value is true. We get the same thing for 3 is greater than 2 is greater than 1. Again, we can apply the parentheses to figure out what is going to evaluate first. First, it's 3 is greater than 2. That is true. So we're left with is true greater than 1. And we saw that true has a value of 1. So is 1 greater than 1? No, they're equal. So this is going to be equal to false. All right, so overall we get that this line is false. Now we get to this last question, type of array. And this is, in my opinion, the best question in the set because it drives at a fundamental concept in JavaScript. Almost everything is an object, even arrays. So to dig into this, let's start with an exploration. First, let's set up a variable called colors, which is set to an array that contains the item red and the item blue. And then let's set up an object called color map. This color map is going to have two properties, 0 and 1. That first property is going to map to the color red, and the second one is going to map to the color blue. Now, for both structures, if we want to access the red value, we could use bracket notation. So colors of 0, which is accessing the first item in the array, returns red. Likewise, color map bracket notation 0 is returning red. And now you can see the similarities between the structure of the array as well as the object. You can use bracket notation in both cases. So under the hood, the array is actually represented as an object where the properties themselves are the relevant item index numbers. And then the values are still those items and values themselves. Now, this isn't the most precise way to confirm that an array is an object. For that, we can try the property test. In this test, you assign a variable to a value, then attach a property to that value, and then see if that value is still retained. If that value is still there, well, then you know that the original value is an object. For example, say we have an object called map. We'll say map.test equals the string foo. So now let's access map.test. The value is retained, so we know that the map value is an object. We can do this for an array too. How about an array called list? List.test equals foo. If we access list.test, again, the value is retained. Cool. Now, this shouldn't work for primitive values though. Primitive values are not objects. For example, var count equals 5. Count.test equals foo. If we access now count.test, you'll see that the value isn't retained. What is evaluated is undefined. This shouldn't work for other primitives as well. So how about a string called greeting set to hello? Greeting.test equals foo, and then greeting.test evaluates to undefined. Overall, this property test is showing us that primitives like numbers, strings, booleans, undefined, and null aren't objects under the hood. But what is an object under the hood, as we saw, was an array. So based on that, this type of an array, will it return the string array or something else? Well, let's go ahead and check. Type of array actually returns object. So the underlying implementation for an array itself is an object. All right, now we've completed the interview question, but before we move on, there's still something else that would be interesting to dig into. Let's go ahead and try the property test on a function. So if we set up a function called info, and we're going to assign it to a function expression, let's say that info.test equals foo, and now info.test, you'll see that it returns the string foo. So under the hood, the function is acting like an object. However, let's check the type of a function. So check type of function, and what you're going to see is that the type of function is function. Even type of info also returns function. It doesn't return object like an array. But both the array and a function pass the property test, so it should be an object under the hood. To understand how and why this function is passing the property test but returning a different type than object, you have to dig into prototypes in JavaScript. Now, prototypes are a big and advanced concept, and they're going to be the topic of a few videos later. But overall, this property test can show you in the meantime which values act like objects under the hood. All right, that wraps up this whole set of interview questions. Admittedly, a few of these questions were a bit sly in their structure, but they drive at fundamental concepts in JavaScript. And those fundamental concepts include, one, that it's a dynamic language, so you don't have to declare the types of a variable before you assign it their value. Two, it's a weakly typed language, so if you have an operation that involves different data types, implicit type coercion works under the hood. And three, almost everything is an object, except for primitive values like strings, numbers, booleans, undefined, and null. But almost everything is an object, like functions and arrays, and of course objects themselves. Alright, overall I hope you enjoyed this video and that you have a stronger grasp on JavaScript types. I'll see you in the next one.